So today's lesson, we saw that one problem. For the installation shown below, we need to determine is a consumer makes a voltage drop, B summary voltage drop, C final circuit voltage drop, and D total voltage drop. So this is our problem given. So here you can see that here is point of supply, and there are three-phase wire and connected to the main switch board and single-phase wire. This is the connected between the main switch and the distribution board. This is a sub main, and from the distribution board to the load, this is final circuit. So all the sub main and final circuits are the single phase, and point of supply to main switch board is consumer main is a three-phase supply. So in this case, our consumer main given size is a 35 millimeter square HLPE. So this is the copper given. So the how to connect is a leaflet touching. So leaflet touching. In this case, maximum demand 125 ampere. The length is a 36 meter. So this is the consumer main. And sub main, the wire size is a 10 millimeter square V90 wire, and this is the copper. Is the connection that copper wire, and also the maximum demand 50 ampere. Length is a 25 meter. And final circuit given size 4 millimeter square V90. So this is the copper wire. The 2C plus E means the 2 cores and the earth wire. 2 cores. So this is mean the 2 core mean this is the sub main single phase system. Also the copper 2C plus E. So this is will be the also the this is the 2 core and the earth. So this is the also single phase. So maximum demand 25 ampere. Length is a 31 meter. So those are the specification of the consumer main, sub main, and the final circuit. Okay, so firstly we have to find out the voltage drop. So to find the voltage drop, we have to use this formula. VD equal to VCLI divided by 1000. So VC is the unit voltage drop. We have to find from the table 41 to the 50. A is the length of the wire, and I is the maximum demand current. Those things you have to find out. So in this case, a leaflet touching. So they are table 40 to the 50. Those tables are for the unit voltage drop. So how the tables are which table have to utilize? We have to use this equation, this relationship. Table 40 single pole. This is the 3-phase installation. We use the table 40. Table 41 copper. Table 40 copper single pole 3-phase. Table 41 copper single core leaflet. Table 42 copper multi-core. And similarly, table 43, 44, 45 for the aluminum, 46, 47, 48 for the flexible cable, 45 for MIMS, and then 50 is the area conductor. So this is the how tables are, which is the material of the cable, and how is the installation method. Depending on the material table and the cable and the installation method, we have to select the appropriate table. So in this case, this problem is a copper single core, and this is a 3-phase. So this is the wiring enclosure. So we use that table 41. So we apply that table 41. Leaflet touching, we use the table 41. So in this case, we find out the table 41. So HLPE is 110 degrees centigrade. So we use the HLPE table. So table 41, we look at the table 41 here. So HLPE. So HLPE is 110 degrees centigrade. And also from this table, you can see that here is a done. It's crossing the area of cable, and this is a temperature. So this is the temperature. So we have to select that this table. This from this column, we have to select the appropriate crossing the area, and then we have to select the VC value. So this value selection, what you get is a 35 millimeter square, 110 degrees centigrade. So here is a 35 millimeter square, 110. So what you have to use is 1.25. 1.25 millivolt per ampere meter. So this is a 35 millimeter square, 110 degrees centigrade. 1.25 is substitute. So substitute there 1.25. But this is for the 3-phase VC. what you want is we need a single phase BC because of we have to utilize it as a single phase system. So the single phase BC is 3-phase BC divided by 0.86 is that formula. So the 1 by 2 divided by 0.86 is 1 by 4 millivolt per ampere meter. So this 1 by 4 that we substitute in BC. Then is already given a 38 meter and the maximum demand current 125 divided by 1000. You call it 6.84 volt. Similarly, we also have to use it as sub-main because sub-main is a multi-core cable. So this is for the 2-core and RC. This is a multi-core cable. So the multi-core is where we utilize the table 42. So this is the table 42 used here. So the 10 millimeter square and the V90 90 degree centigrade. So 10 millimeter square 90 degree centigrade. Table 42. We select the table 42. 10 millimeter square 90 degree centigrade. So this is for the 4.05. So this is for the we call it 3-phase voltage drop. So 4.05. 4.05 divided by 3-phase voltage drop 0.86, you got the 4.676. So we substitute here V equal to VC and by 1000. 4.676 multiply 25 into 50. 25 is a net and 50 is a 50 is a maximum demand current and we got a 5.845. Then we also use a final circuit. Final circuit is a 4 millimeter square. 4 millimeter square 90 degree centigrade. So 4 millimeter square 90 degree centigrade we utilize the tables 42 as well. So in this case from the 4 millimeter square 90 degree centigrade. So you got 10.2. So this 10.2 we substitute here. 10.2 substitute. So 10.2 divided by 0.86 you got 11.77 volt. So this voltage is VC. This VC substitute. Then is given there's 31 meter. And current is 25 ampere. Substitute here. And we got a 9.12 volt. Then we find out the total voltage drop. So total voltage drop is sub-main, consumer main, sub-main, final circuit. You add everything, you got a 24.1 volt. So this is the way we calculate. And this one is a dilating factor. When the multi-phase circuit are running in the same conduit or trunk, the dilating factor is utilized to increase the current carrying capacity and after the conductor size. Because of the in the single, all the multi-phase circuit are run in the conduit, so they are producing the inducer voltage. Because of the magnetism, negative magnetism inducing the induced voltage. So this induced voltage will increase the current. So this is why we have to change the cable size. We have to select the bigger cable size. Okay, so based on this one, we select this problem here. The maximum demand current of the sub-main in the non-domestic installation is calculated to be the 120 ampere. So this is maximum demand current 120 ampere. The selected cable is a 4-core non-armor V90 insulated and a sheeted circular copper conductor. The installation of cable is clipped directly to the internal wall with the 4 other circuits, all touching open to air and produced by the circuit breaker. Length is 50 meters. So this is for this cable and then the other 4 other circuits they are connected together. They are touching, they are open to air and they are protected by the circuit breaker. Length is 15 meters. So in this case, we have to find out. In this case, the installation is a 4-core. 4-core means a 3-phase wire is a 3 active wire, is a 3-core, and then additional and neutral wire is this is a 4-core. Open to air, this is the unenclosed. So that we have to select that table 3/1. Table 3/1 unenclosed. So that firstly you look at the table 3/1 unenclosed. So we look at the table 3/1 back. Okay, this is a table 3/1. Table 3/1 select and 3-core. So this is 4-core means 3-core plus 1 neutral wire. 3-core. 3 go is a which table, which row you have to select. This is a 3 single go given. 3 single go given. So this is a 3 go given. Look at here. 3 go given. 3 go given. We have to select that item 10 or 11. So 10 or 11 you have to select. In this case, table 13, 14. This is for the V90. V90 is a V75, V90, and V115. So this is three saturation. So this gives us table 13, 14, or 15 you have to select. So I done 10 to 11 to be selected. So that this is 3 go. So in this case, that table is V75 because of the given is a this given is a V90. V90 so is given. So this is therefore that we have to select the row 13 have to be selected. Clip it to the wall. So in this case, clip it to the wall is a row 13 have to be selected. Three single cable clip it to the wall. So this is a 3 go cable. This is for a suspension. But 3 go cable clip it to the wall is a this is a we have to select the row 13. 3 go cable. So the 3 saturation 11, 10 or the 13. 11, 10 is we have to select on the supported by the ladder or vertical or suspension. In this case, item 10 to 11 to be selected. Row 10 or 11 selected. But here is a clip it to the wall. Therefore, we have to select the row 13. 3 go cable, clip it to the wall, row 13 selected. So table 13, 14 or 15 have to be selected. Table 13, 14, 15. And derating is the tables are 22. So they have to be find out. So in this case, clip it to the wall, row 13. In this, so column 5 to 7 or the row 15, column 4, 5. So in this case, 13 for the V75, 14 for the V90, 15 for the V11, 120 degrees indicate. And table 22 is a derating. So those things I have to find out. So based on the here, we have to find out the derating factor. The derating factor is table 22. So there will be the touching of space or touching. So this is the way to select. So we look at the table 22. We look at table 22. This is the derating factor. From here we got there's a derating. So we look at the table 22. So all are touching. So all touching. So here we see a derating table. So derating is given the item 3 or 4 because of the clip it to the wall. So item 3 or 4. Item 1 is a bunching air, 2 is a bunching surface enclosed, 3 or 4 is single layer on the wall touching. So therefore that you have to select the item 3 touching. So this is the item 3 touching, and we look at the how many circuit. So how many number of circuit we look at? How many number of circuit is a 5 circuit. With the other 4 other circuit mean this is the 5 circuit. 5 circuit item 3. So 5 circuit item 3 you look at. So this is the item 3. So 5 circuits. So this is the reading factor is 0.73 we got it. So this is 0.73. This 0.73 we got. So this 0.73 is a derating. So the maximum demand current divided by 0.73, you got a 164.3 ampere. So this current you have to be utilized. Because maximum demand current is at 120 without derating. If you derate, derating factor is 0.73. So 120 divided by 0.73, 164.3 have to be utilized. So this is the name we got as a derating factor. So based on this derating factor, you have to find that this is the maximum demand current we can get by using this derating factor. So that this problem we have to find out there's a gradient factor. So by this way we can find out the gradient factor. So this is the maximum demand current, we get it. So this problem is we can find how to find out the gradient factor. Okay, the next one we can talk about the electrical engineer trade practice. To page 22. Okay, the next one will be last week we talking about I had talked about the alternatives power supply and standby generator. Now we have to think about the factors to be selected the alternator. In this case, we have to concern about the voltage, current, frequency, power, and power factor. Those are the factors to select the alternator. So this is main power supply, circuit breaker 2, 3, 4, and standby generator, essential load, non-essential load we connected. In this case, the circuit breaker 1 is manually operated, circuit breaker 4 will be manually prepared by disconnecting non-essential load. Standby alternator is start, run to speed, and the CV circuit breaker 2 is closed when the supplying power is essential load. So supplying the power to essential load. This is for the configuration of the main power supply and the circuit breaker arrangement and the standby alternator. So this connection is an automatic changeover system. There are two feeder 1, feeder 2, and this will be the three-phase power supply and the load and automated transfer switch. This is connected to the all load and this is standby generator. So this is the arrangement of the standby generator and the automated power transfer. So when the supply may loss, the control system sense the loss and operate the automated transfer switch. At the same time, the standby generator is started and then run up to speed. Once up to speed, the standby generator then supply the connected load. The control system will operate the appropriate circuit breaker to disconnect any non-essential service. So this is the ways of configuration of the standby generator and the load. So then we also talking about in this case, we have to concern about the cross 4x12 of the year 3000. So cross 4x12 of the year 3000 is a concern with the electricity converter, and this is the type of electricity converter. So in this case, we have to utilize the interruptible power supply system have to utilize. Also, the semiconductor power converters are utilized, and a voltage stabilizer need to be utilized, and generator motor, generator set, and rotary in converter die. So those are type of the electricity converter. They are the UPS, interruptible power supply, or semiconductor power converter, and voltage stabilizer, motor generator set, rotary converter. Similarly, electricity converter must be installed with the independence of isolation switch. So all the electricity converter, we need to be installed with the independence of isolation switch. This is the cross 4x12.4 of the year 3000. All the electricity converter protection, every sub main or final circuit outgoing from the electricity converter shall be individually protected. This is the cross 2x5. Additional protection need to be provided for the cross 2x6. So this is the cross 2x5, cross 2x6 of the electricity converter protection. So here is a converter, this is low. In this case, must not be bypassed by the PLC. So where you have the connection between the converter and load, they must not be bypassed. So this is the crossing across 4x2 and 4x1. All the RCD and the electricity converter residual current device need to be utilized. So they are mentioned in the 4.12.5.2.2 of the year 3000. RCD sharing type of the switch, RCD sharing of the type suitable for the waveform of the particular inverter. And we also need to provide the earthing system for the standby generator. So we must follow the cross 4x12.6. So protected earthing connector shall not be switched. Ambient connection remain intact. Earthing for the engine-driven generator set is a mentioned must follow the ASNZ 3010 standard. Also, the standalone power system, we must follow the ASNZ 4509. Photovoltaic array, we must follow the ASNZ 5033. Inverter system must follow the ASNZ 4777. So those are appropriate rule regulation and the standard related to the standby generator system. So that in this case, we also have to utilize the standby generator. Standby power system are intended to provide the power at the specified voltage and the frequency. Appropriate voltage and frequency, the standby generator must provide the power. So UPS are the interruptible power supply. So UPS convert the DC to AC, and our conductor must not be switched. And standby generator require the prime mover. This is powered by the diesel engine, LPG gas or natural gas. So the converter RCD connected. So the RCD waveform must suit to inverter output. So this is also important aspect. So that there are also the difference between the inverter and the rectifier. Inverter function is converting the DC to AC, rectifier AC to DC are converting. So the cross 7.34 follow the incorporating the battery system. So the cross 4.3 is when you utilize in the UPS, we also utilize the battery. So class 7.3 on the AF3000 is mentioned about the incorporating the battery. So the earthing conductor side had to be utilized. So in this case, our earthing conductor side, we have to refer the section 5 of the AF3000 because of the, depending on the supply current, so KVA multiply 10 root 3 and 400 volt, you got a current. So based on the current, we have to select the protected earthing conductor side. It must be on the table 5x1. So table 5x1 of the AF3000. Now I show you the AF3000 table 5x1. The 5x1 of the AF3000 is mentioned about the selecting the earthing conductor side. So this depending on the active current, we have to select the earthing conductor side. Earthing conductor and the earthing conductor side relationship. Table 5, I'm looking for the table 5x1. Earthing conductor side. Table 5x1. Look at table 5x1. I will show you the table 5x1 of the earthing conductor side. This is the section 5 is especially for the earthing system. So depending on the earthing conductor side, we have to find out the appropriate earthing conductor side. So this earthing conductor table is mentioned about the table 5x1. So I looking at the section 4 the table 5x1. Here table 5x1. So here is a minimum earthing conductor side. So in this case, depending on the earthing conductor side, depending on the maximum demand current. Based on the maximum demand current, you set the earthing conductor side, and then this is for the earthing conductor. Earthing conductor can be the copper or aluminum, so the side of earthing conductor can be utilized by referring the table 5x1. So this is the adding conductor side. So based on the table 5.1, you can select the appropriate adding conductor side. So we also use a overcurrent protection device. Overcurrent protection device shall be located as close as practicable to the output terminal of the electricity converter so that the unprotected interconnection conductor are as short as practicable. So this is the requirement. Overcurrent protection device shall be located as close as practicable to the output terminal of electricity converter so that the unprotected interconnection conductor as short as practicable. So this clause are 4.12 by 5.2 ones are mentioned about that one. And also that we also need to install the independent isolation switch. So that each electricity converter shall be provided with the independent isolation switch in accordance with the clause 2.3.2.2. So electricity converter shall be arranged that it cannot supply energy upstream of the point or the connection to the installation either directly or indirectly. So this is the 4.12.3. So this is electricity converter, this is the motor. So in this case, we have to utilize follow the electricity converter, must follow the clause 4.12.4.1D. And here is the switch. This switch must be the manual only switch. So this is the clause 4.12 by 4.1D or AS3000. Those are the appropriate rule and regulation or the AS3000. So that the next one we need to install the installation of the battery to supply the electricity energy in the form of the chemical energy. So this is for the batteries principle. So charging system, when battery are charged, electricity is converted to chemical, and discharging chemical are converted to the electricity. So cells are the primary cell and the secondary cell. So this is the series connection of the battery. So the 1.50 is the E1, E2, E3, E4. Then we are adding that to the ED is a E1 plus E2 plus E3 plus E4. So this is the series connection. So in this case, our series connection is an increased voltage. So each cell got the 1.5 volts. So there are 4 1.5 volt cells are added together to total voltage is 6 volts. And current is a common current is flowing. This is the parallel connection of the battery. Same voltage batteries are to be connected in a parallel. So in this case, the E1, E2, E3 are producing the I1, I2, I3 currents, and the combination of all current is the IT. So IT is the combination of current. So the electrode potential should be the aluminum 1.67 volt and the lead is 0.13 volt. So the electrode material can be this is the hydrogen. So this will be the hydrogen 0, copper 0.34, carbon 0.74, silver 0.8, and gold 1.42. This is the electrodes potential. Depending on the electrode material, there will be the electrodes potential. Then also that we can also like the type of the dry cell. We use the dry cell we utilize. So there will be this is the calculation of the potential. So copper and the zinc are utilized. So it is copper is 0.3 volt, zinc is a 0.76. So zinc minus 0.76 minus, so then you got a plus. So this is a 1/2 volt. So this will be the copper calculation. And here is a connection installation of the dry chemical cell. So this is the positive terminal is carbon and this is negative terminal. So here negative terminal is at the shell and positive is the electrode. So electrode and the electrode is zinc and this is the copper. So that installation, the potential will be like this. So in this case, carbon and the electrode, this is carbon, this is zinc. So what happens is the carbon minus zinc. So carbon is 0.7 volt, zinc is minus 0.76. So we got 1.5 volt. So this is the way we got the every cell got the 1.5 volt. So we use a electric torch on the alarm circuit. Also, we also use a body weight testing device and body weights are radio. Those are the devices we are utilizing. Those are copper. So we also utilize a tables of the laser pipe. This is for the type of the material and the application. So chemical reaction slow at the low temperature. At the low temperature, chemical reaction slow. So that we need to store at the below the 50 degrees centigrade. When the internet activity increase, so it will be affected with discharge, it will be affected. So therefore the nevers are crush the primary cell. If you crush the primary cell, it can explode. Cell can be get, they are dangerous. Therefore we have to utilize appropriate protection devices. So the secondary cell are the rechargeable cells. Battery, each cell has a different energy density. The energy density of the cell is a measure at the amount of the chemicals electrolyte per unit or the per volume, which can be stored in the battery. So this is the ways how the electric cells are utilized. So this is for the type of the nickel cadmium cell, nickel metal hydride, and lithium ion, and the lead acid. So this is for the appropriate weight, and they are also the weight per liter, and their relationship table. So we have to find out the nickel voltage is 1/2 volt, cell voltage is nickel cadmium cells voltage 1/2 volt, cell discharge is 10% per month, and cell durability is 2000 cycles. You can charge and recharge up to 2000 times. So this is the nickel metal hydride cell, so the electromagnetic and the arrangement connection. So they are called a limitation because it needs a protection circuit to limit the voltage, also moderate the discharge current, and also the transportation regulation must be followed. Lead acid batteries there's a connection here. So lead electrode is electrode lead. So lead is a peroxide and a spongy lead. So positive terminal is we use a lead peroxide. Negative terminal is we use a spongy lead. Electrolyte is we use a sulfuric acid and water combination. Sulfuric acid density determines the strength of the battery. Lead acid voltage is a 2 volt, 2.1 volt per cell. Energy density is 60 to 100 watt per liter. Peak performance at the 32 degrees centigrade, 27 degrees centigrade battery capacity is half at the rated output. So this is the way we use it. Also, that we have to test the lead acid cell. We use a hygrometer. We use the hygrometer to test the electrolyte. So the electrolyte depending on the temperature and the age of the cell. So this is for the in this case this floatings indicators density of the electrolyte. So in this case, is the density the 1250. This is the fully charged. So this is the 1250 kilogram per meter cube or the 1/25. If the 1180 is a discharge. So 1180 kilogram per meter cube is the 1/1. So when you measure the density 1/25, this is the fully charged, and 1/1 is totally discharged. So we also use the comparison between the type of the cell, lead acid, nickel ion, nickel cadmium, alkaline, and also the lithium ion, lithium polymer. Those cells need to be they are have to be the comparison, how the cells are utilized, what are the efficiency, those they have to utilize. So the cell voltage circuit, watt per kilogram, and the efficiency, those are the factors determining to select the appropriate type of the tri-cell or the battery. So the installation of battery, we must follow the AS 3011.1 1992 edition. Similarly, we must follow the AS 2676.1. This is the related to the installation, maintenance, testing, replacement of the secondary battery. So this is the way you go. And also the ASR 3022 must be utilized to see the cell. So in this case, commissioning procedure. When you commission the battery cell, they must have the sufficient ventilation and also adjust to the supply voltage and fully charged on the acceptance test on the side is important, and maximize battery at the constant temperature 25 degrees is important. And also we must follow the safety precaution because of the cell has to be charged at a specific rate for the set time. If the degree of the cell operating is to be the maximized. So in this case, appropriate safety procedure must be follow. Cell grouping, cells are charging. We have to utilize the appropriate rate for the set time to charge or discharge the cell. So in this case, we also have to know about the danger because of the battery can cause a fire explosion and sometimes without installation can damage the battery. And also we have to utilize as protective clothing need to be utilized when we are using with the battery. And also the safety footwear, apron, safety glasses must be utilized. So all the clearance, all the isolation, all the clear and discharge should be carried out with this appropriate installation method. So this is also important. So that the C cells are producing a designated current, rate is a loss C cells they are producing a designated current. And this was we must follow the appropriate manufacture recycling procedure. We need to maintain the battery. So we need to clean the terminal of the battery. We have to try to give the good electrical content. Suitable material for the connection must be utilized. We have to check the electrolyte level. We need to clean the battery case. We need to protect the extremes of temperature, not to charge or discharge at the excessive high current rate, and the rate of the charge and the discharge at a specific design level is important. So the cell capacity and the discharge rate are depending on the cell capacity is based on the ampere hour method. So the 1 ampere hour is produced by cell when the 1 ampere flow of the period of 1 hour. So this ampere hour calculation is I multiply T. It is a capacity in ampere hour, I is a charge current, and T is a time hour. So that we solve this problem. We calculate the time required for the discharge of the 200 ampere hour storage battery is a constant discharge current of 50 ampere flow. We have to assume so the ampere hour I multiply T. So the T is a ampere hour by I. So ampere hour given 200 and also the current 15. So you got a 30 by 3 ampere. Similarly, we also have to utilize that if the storage battery is was a discharge at the constant rate of the 4 hour, how much current is to be lost? So in this case, ampere hour I multiply T. So I equal to ampere hour by time. So in this case, 200 is an ampere hour given, 4 hour. So it's given so that you got it, discharge at 50 ampere. So this is the next one is an ampere hour efficiency. Hour efficiency NAA is equal to ampere hour output by ampere hour input. NAA is our efficiency. AH out is an ampere hour delivered during the discharge. So I out multiplying time. Ampere hour in is ampere hour supply during the charge is I in multiplying time. So this is the way we calculate the ampere hour. So this problem, we need to calculate the time required to charge the 500 ampere hour storage battery with a constant current of 70 ampere. So assume the ampere hour efficiency of the battery is 90%. So the ampere hour efficiency is AH out by AH in multiplied 100. So 90 equal to I out multiplied time divided by 500 into 100. So the I out is 70. So the from here you solve it, you got the time is 6.4 hour. The next one is the battery rated at the 150 ampere hour is to be charged at the constant current is 8 hour. What will be the charging current is the ampere hour efficiency 90%. So in this case, we is given the ampere hour is output is 150 ampere hour input I in multiplied T. So NA is AH out by AH in by 100. So 90 equal to AH out is 150. AH is I in multiplied T into 100. So T is 8 hours. So you substitute here. Then you got the IA is 20.8 ampere. We got calculated. So this will be the connection of battery E. E and out of battery here be the terminal voltage, and I is a low. There are small I is a battery internal resistance. So I current flow to low. So the E is a V multiplied IR. This is the way we calculate it. So the I equal to E divided by RA plus R. Equal has the resistance of the 0.5 ohm is connected to the cell with the open circuit voltage of 1.5 volt. Find the current flowing on the terminal resistance of say the 0.1 ohm. So this is the way you have to calculate. So in this case, this diagram is given here 1.5 volt and 1 I is a 0.1 and I is a 0.5. So the I equal to E divided by I plus R. So 1.5 0.5 plus 0.1, you got the 2.5 ampere. The next problem is that A cell has an open circuit voltage of the 1.5 volt when the current of the 880 milliampere flow in the cell. Terminal voltage drop to the 1.15 volt. We have to calculate the terminal resistance of the cell. So that E equal to V plus IR. So that 1.5, 1.15 plus divided by 0.88. So that then we calculate the R value. So this is R we calculate that. The name is a cell has the terminal voltage of 13 volt. Internal resistance is a 0.58 ohm. We need to calculate the open circuit voltage if the current of 250 milliampere flow in the cell. So in this case, we use that we have to find out the E voltage is a 1/3, I is a 0.58, and then I is a 250. These are milliampere. So E equal to V plus IR. So V is a 1/3, I is a 0.125, I is a 0.58. So you got 1/205 volt. So this is the connection of the internal resistance R. So the battery called the E R. So that this is the RT equal to NR, ED equal to NE. So N is a number of the battery. So this is how we calculate that. The next one is a 12 1.54 cell, each with the internal resistance of 0.3 ohm, are grouped in the series to supply the external current, external circuit having in a resistance of 11.5 volts. And determine the currents are supplied to the load. So ED equal to NE. So the each engine number of the battery, each battery got a 1.5 to 18 volt. RD equal to NR. So the RD is the total internal resistance, and is the number of battery. I is the internal resistance of each battery. 12 by 0.3, you got the 3.6. So therefore, we write down the equation I equal to ED by RD plus RD. So 18 divided by 11 by 4, 4 plus 3.6, you got the 1.2 ampere. If you connect the battery in parallel, so that this is each ER is here, ED is equal to E, RD equal to R divided by number of battery. So therefore, we also have to calculate this problem. So these are 1.5 cell, each got an internal resistance 0.3. They group it in a parallel. To supply a load resistance 0.275, we have to find out the current. So the ED is the 1.5 volt, RD equal to R divided by 0.3. So I is 0.3 by 12, you got a 0.25. So I equal to ED by RD plus R, so the 1.5 divided by 0.275 plus a 0.25, you got the current is a 5 ampere. So this is how we calculate it. So this is what the 12 batteries are we connected here. The 12 1.5 batteries are connected in series, connected in the terminal. So in this case, we have to arrange the terminal. So this is for the all batteries are connected 12 number. So this is where that we calculate the how the to the current and to the voltage. The calculation we got it. The next one is we need to calculate the continuous current. That the battery of 300 ampere hour rating is a discharge at a 5 hour. Is an ampere hour output is reduced to the 80% of original 10 hour rating. So in this case, 80% reduction on the 300 ampere hour is a 0.8 by 300. You got a 240 ampere hour. So we have to find out the discharge time. Discharge time is given the 5 hour. So the current had to calculate. So the I ampere hour by T. So the 240 by 5, you got a 4 ampere. And the next problem is 12 volts of battery consisting of the 6 cells require the 14.7 volt to charge at the 20 ampere. Find the internal resistance of the each cell after the charging has been completed. So this problem here. So that will be the E is the 14/7, V is the 12 volt, E is the V plus I into RD. So E 14/7, V is 12, I is 20, so then we got the RD is a 1.35, 0.35 ohm, 0.135 ohm we got. So all the batteries are charging connected in series, RD 0.135, so that we have to find out the each internal resistance. So the RD equal to 6 multiplied R is a 0.135 is a 6R, so the I 0.135 by 6, you got a 0.0225 ohm, we got it. Each of 1.5 cells are arranged in the 2 parallel group, and if the cells are connected to the 12 ohm load, we have to find out the current. So this is the battery connection. So in this case, each branch voltage is you call the 6 in series, so the 1.5 multiplies are 4, you got a 6 volt. And also the total resistance of branch, so this connected in series, so the 0.3 multiplied 4, you got the 1.2. But two are connected in parallel, so the voltage is 6 volt, but the RTT is R branch by 2, you got the 0.6 volt. So the I equal to E by RT plus RL, so the 6 divided by 0.6 plus 12, you got the 0.476 ampere. So this is the way we calculate it. So then based on here, you have to do the load tutorial. So this is the tutorial question. Tutorial questions are, you have to do the load tutorial question. Also the do tutorial question. So that this lesson, in a trade 2, I have explained you about the standby power supply, and requirement of the generator, and also the appropriate AR3000 rule. Also, I explain you about the battery. Then we also talking about the electrical trade 1. What's your practice? So this is a this is for the dismantling and the assembly. Dismantling and assembly method. So when you dismantle the assembly, we have to utilize a template. How to dismantle, so this is template have to utilize. So in this case, you have to remove the plate cover from the motor. We use a wheel puller or tension wrench, spanner, screwdriver, and heating equipment. Feeler have to utilize. So this is for the wheel puller connection. This is the wrench to remove the nut. In this case, we also utilize the screwdriver to remove the screw, solvent as we have to cleaning agent to remove the grease and the dust. Heating equipment, we use the torch to expand the metal to give it enough clearance. Feeler gauge are utilized to measure the clearance, so this is a feeler based utilization. Similarly, we are using the electrical machine. Electrical machine must be truly cleansed before dismantling or reassembled to ensure that the good electrical contact between the maiden surface or the moving and stationary part. So this is the carbon brush we have to commutator, we have to utilize the electro cleaner. Short circuit will not occur between the insulation component and the arc. Damage to insulation or electrical conductor can happen, so that we have to fire hazard can happen, and the affected are more plastic, affected more plastic component. The cleaning methods of the electrical machine need a large gas and deposit need to be cleaned by the scraping of the wire brush or the mild solvent by using a crushing, and also the blow internal resistance. We utilize a compressed air, electrical maiden survey. We have to utilize a compressed air solvent. So all the we need to wear the appropriate safety goggles, and also the after cleaning we have to inspect the motor to determine the removable item, or we also need to remove the component. Also on the shaft, we have to check the exhail or the flow of the machine, also the motor plate. So this is the ways how to dismantle the motor and what are the important requirements. So this is the vernier clipper. This is vernier clipper to measure the basic measurement. This is the micrometer. To do this low tolerance measurement. Here is a wire gauge to measure the gauge of the wire. So vernier clipper is we can utilize this equation, main scale and the vernier scale. So the main scale and vernier scale, so main scale plus a vernier scale indication in line with the main scale multiplying 0.02. This is the vernier meter rating. Micrometer is a main scale plus a micrometer scale. So number scale we also call number scale in line with the horizontal multiplying 0.01. So this is for the vernier clipper connection. So in this case, we utilize the vernier clipper diameter of the white bolts marker and also depth of the white bolt marker cap, and we also need the thickness. We have to measure thickness of the sheet metal. Micrometer are we utilize to measure the diameter of the white bolt marker and also the thickness of the sheet metal and the thickness we utilize. So those are the exercise regarding the how to test it. So this is the appropriate you form of the measure the diameter and the thickness by using the micrometer. So then we also have to talk about the dismantling. When you do dismantling, we have to utilize cleaning. We have to collect the required tool and equipment. We also have to follow the dismantling techniques. We measurement of the original assembly have to be followed. We have to take the appropriate mechanical data on the length, gap, clearness of the machine. So we use a ruler to measure the length. We have to striver, vernier, we measure the diameter, dash, micrometer, we measure the diameter, and feeler gauge, we measure the gap. Original screw nut have to be take care of. Also, they take the nameplate data of the machine, alignment of component. Also, we have to take the photo of the component assembly. Those are the before dismantling. Those things you have to take care of data. So in this case here, you see that the type of the technique is that this is the end flow. We have to measure. In this case, feeler gauge you to measure. And also die indicator is that you measure the alignment of the machine. So we're going to put the shaft to the machine and then use a ruler to measure the flow and pour through from the end. And then also pull the shaft outward, and then you also measure how far the shaft and the pour throughs are and are healed. And also we have to document appropriate excess floating have to be measured. Airflow is a use appropriate feeler gauge to determine the airflow. And you have to use a glass meter to measure the shaft. Those things have to utilize. So this is for the airflow measurement, and this is the die indicator measurement we utilize. Put the shaft into machine and use a ruler to measure how far the shaft protrudes from the end sheet. Also pull the shaft outward and then measure how far the shaft protrudes from the end sheet. We have to document the difference of the axial flow. So airflow is a use appropriate feeler gauge to determine the airflow. We have to clamp collar to the shaft and then mold the shaft. So here we utilize a marking of the end blade. Before you are dismantling, you have to measure the marking. For the marking of the end blade, you have to utilize. Marking of the end blade, so that on the end blade, you have to mark out. So end blade body, you have to put the mark, appropriate mark have to utilize, also screw nut. So this is important to take the mark before the moving the end blade from the body. When the refitting the mark on the body and the end blade must be exactly aligned so that the screw and nut can be fitted. Here is that you can see there's check the end sheet around the shaft for the bearing retainer screw. If present, remove these. As the parts are removed accurately and then inspect them for the damage, place them in the tray or the container in a logical order so that they can be identified and reassembled. So the make sketch and the photo of the assembly. So here is the location or the appropriate photo or the size or the nut have been measured, appropriate indicator have been utilized, appropriate how the nut have been taken out logical order. Then take out the nut, take out the bolt, take out the cap. So this is the first nut have to take out and bolt have to take out, cap have to take out. So in this case, I'm going to put into an appropriate tray. Tray 1 is that you put the nut, tray 2 bolt and put bolt, and the tray 3 that we have to put the cap. So this is the appropriate logical order. We have to put the dismantle component. So the assembly and dismantling is also important aspect. So that we have to loosen the end screw holding and the dry end. She loosen any screw holding the dry end and she do the mortar frame. Do and she so that use a saw method, a drip and a saw face mallet. So exercise not to damage a cast iron sheet. You also look around and loosen end sheet. You can safely remove it or not. It's also the clear any obstruction. then remove the screw and carefully remove the end sheet. So this is for the DC machine. We have to remove the end sheet. Here is shaft. This is armature. So that on the end sheet, there may be the brush holder or centrifugal switch. They are installed. So that they need to be carefully removed. In this case, electrical connection. Before the mobile, you have to know the electrical connection before. So in this case, I will also utilize the moving the bearing. So this is outer race. This is ball inner race. So this is the it's configuration of bearing. This is ball. This is outer race. So that you have to apply the force to the inner race. Remove the face or the pushes the race pass. Only once the bearing is not at the C dot. And also the blow dry with the compressed air. Do not allow the bearing race to spin. This will damage the bearing track and not to damage the bearing service also improve. So this is the explode view of the electrical generator. We have to take out so you can see that those are views. Those are components of the electrical generator armature. So we have to draw the explode view of the machine. When you are disconnected, dismantled, you have to draw the explode view. So this is the explode view. So we have to reassemble. In this case, you have to measure the appropriate quiet span of the motor. You have to measure. When you reassemble, reassembly usually follow the removal, reverse process on the removal bearing gasket C. So you have to install a bearing, roller bearing, and removing the race. And then also the stationary race is a light push out. So do not take this new bearing from the ace back. And also the any gasket C spacer have to be appropriate fitting important. So this is for the explode view. So when you are this reassemble, we have to follow the appropriate reverse process on the explode view. So that list of the two head required for the dismantle. So you need to when the wrench, spanner, wheel puller, screwdriver, hammer, filler gauge, ruler, driver, micrometer, vernier, and also cleaning equipment. Why must we clean the electrical motor? So in this case, to clearly see the assembly component or to easily remove the component. These two ways of which we help you to remember how to reassemble the motor which you have just dismantled. So in this case, we have to draw the logical storage of equipment. Also, you have to utilize it, follow the explode view. Why must a motor has the same exhaust flow and how can you measure? So in this case, proper rotating the shaft without jamming. So in this case, pushing the shaft into the machine and then use a ruler to measure the end how far from the shaft and also the pull the shaft over and measure. And then you have to measure the difference than the two measurements. How do I apply the what isolations location do I wish to mark the motor before I dismantle it? So in this case, you have to check the motor frame and the entry for the location of the winner marks and use a appropriate center punch to make winner marks to the entry at the dry end and also the we have to push the winner marks in the frame. What is the process of the reassembly machine? Reassembly machines follow the reverse order of the explode view. So any gasket, C spacer need to be correct type, and the some might side must go the correct position. And also the proper tightening of the screw important on the assembly. Make sure the winner must be realized. So this is the reassembly of the machinery. So this is for the electrical trade 2. Trade 1, we today I explain about the dismantling and the reassembling of the electrical equipment. Then we talking about the diploma. So the electrical diploma. So diploma is we do the advanced diploma. So look at this is for the apply electricity, electrical, electronics. So all the notes you can get from this link. You can download the notes, and then we talking about the diploma. So here diploma video. I show you the access link for the diploma. Electrical 2000 iuiTechnicalCollege.com/electrical diploma 2022.acn. Did you click it? Then we got the electrical diploma. So this electrical diploma, we go down and then we can find there's a YouTube video lesson. So this is a YouTube video lesson for electrical engineering lesson. So this is lesson. So last week we have already talked about the engineering mathematics. So E026 is engineering mathematics. So E026 is we finished lesson 5, multiple integral. Today's matrix Laplace transform, multiple integral finish. Okay, now we're talking about the matrix also finished. We talk about the Legendre function.
Okay, today's topic is the Legendre function. So the Legendre equation is 1 minus a squared y double dash minus 2hy dash plus n into n plus 1 y is equal to 0. This is the Legendre function. So that if you see the equation like this, so you can write down the general equation. So equation is y equal to c1 pna plus c2 is qna. So in this case, y can be calculated c0 into 1 minus n into n plus 1 divided by 2 factorial a squared plus n into n minus 2 multiply n plus 1 multiply n plus 3 divided by 4 factorial to h power 4 and dash dash and the c1 h minus n minus 1 n minus 2 divided by 3 factorial h minus 3 h power 3 plus n minus 1 n minus 3 n minus 2 n minus 4 divided by 5 factorial vs and h power 5. So this is for the generalized equation. And we also use the regardless formula. If you see that Pn plus 1 h is equal to 2n plus 1 divided by n plus 1, but h and the Pn h minus n divided by n plus 1, Pn minus 1 h. So this is called the regardless formula. So by using the regardless formula, we can solve the problem. So the problem given is that Pn plus 1 h equal to 2n plus 1 divided by n plus 1, h Pn h minus n divided by n plus 1 Pn minus 1 h. So in this case, P0 is 1, P1 is 8. We have to find the P2H and the P3H. Okay, firstly we find the P2H. P2H means that 2 is a 1 plus 1. So that there will be a n. We compare with the n plus 1, so this is the n is equal to 1. So that this equation, in the place of the n, you substitute 1. You substitute 1, so what you got the thing says here is h and the P1H, so that will be a here, and the P1 is here. So that will be the P1H value already given. P1H is 8. So that will be the 3H squared by 2. P0H, half multiplied P0H. P0H is already given the P0H is 1, so substitute 1. So by solving this one, P2H we got the 3 by 2H squared minus 1. For the P3H, P3H is a 1 plus 2. So we compare with the n plus 1, so n is equal to 2. So in the place of the n, we substitute the 2 here. So that we substitute 2. So that will be the here is the P2H. So the P2H will be the 3H squared minus half. So that by solving this one, here we substitute P1H. We already got the thing in the P1H at 8. So by solving this one, we got the P3H value. So the next one with the binomial theorem, p plus p power n is equal to 1 plus b plus p into p minus 1 by 2 factorial b squared plus p into p minus 1 multiply p minus 2 divided by 3 factorial p power 3. So this is the binomial theorem. So based on those legenda and the binomial theorem, you have to do this exercise. So topic 14 legenda function, slide 1 to 9, and do the problem 41 and 42. The next one with the partial differential equation. Partial differential equation means that if you differentiate with the h, only the h term have to be differentiated. All other y or z, everything you have to put a 0. This is the partial differential equation. So that if the p equal to f y minus 3h, you have to prove partial differential of the del v by del h. Del means the partial differential. Del v by del h plus 3 del v by del y equal to 0. So firstly, you partial differentiate with the x. So the del v by del h. So the del by del h, we is as a f and a y minus 3. So you differentiate the y. F y minus 3h become the f dash y minus 3h and del by del h y minus 3h. So that will be the del y by del h minus del 3h by del h. So del y by del h 0 minus del 3 by del h becomes the minus 3. So that will be the minus 3 f dash y minus 3h. And similarly, we partial differentiate. So the 3 into del v by del y. So 3, so del by del y, f y minus 3h. So f y minus 3h is the differentiate. You got the f del y minus 3h. Then we use the del y by del y plus del y by minus 3h. So this becomes 1. So this is the y and h, so this becomes 0. So then we use the 3f del y minus 3h multiply 1. So the 3f dash y minus 3h. So that you h del v by del h plus 3 del v by del y is equal to minus 3f dash y minus 3h plus 3f dash y minus 3h. So that will become 0. So the next one with the binomial theorem, p plus p power n is equal to 1 plus bb plus p into p minus 1 by 3 factorial b squared plus p into p minus 1 multiply p minus 2 divided by 3 factorial p power 3. So this is the binomial theorem. So based on those legenda and the binomial theorem, you have to do this exercise. So topic 14 legenda function, slide 1 to 9, and do the problem 41 and 42. The next one with the partial differential equation. Partial differential equation means that if you differentiate with the h, only the h term have to be differentiated. All other y or z, everything you have to put a 0. This is the partial differential equation. So that if the p equal to f y minus 3h, you have to prove partial differential of the del v by del h. Del means the partial differential. Del v by del h plus 3 del v by del y equal to 0. So firstly, you partial differentiate with the x. So the del v by del h. So the del by del h, we is as a f and a y minus 3. So you differentiate the y. F y minus 3h becomes the f dash y minus 3h and del by del h y minus 3h. So that will be the del y by del h minus del 3h by del h. So del y by del h 0 minus del 3 by del h becomes the minus 3. So that will be the minus 3 f dash y minus 3h. And similarly, we partial differentiate. So the 3 into del v by del y. So 3, so del by del y, f y minus 3h. So f y minus 3h is the differentiate. You got the f del y minus 3h. Then we use the del y by del y plus del y by minus 3h. So this becomes 1. So this is the y and h, so this becomes 0. So then we use the 3f del y minus 3h multiply 1. So the 3f dash y minus 3h. So that you h del v by del h plus 3 del v by del y is equal to minus 3f dash y minus 3h plus 3f dash y minus 3h. So that will become 0. So this is a multi-bed integration. You have to find the volume and region R bounded by the parabolic cylinder. Z equal to 4 minus A squared. The places are A0, Y0, YC, and Z0. So that this equation, Z equal to 4 minus A squared. Z limit is a start from 0. So when you put the Z0, so that Z equal to 4 minus A squared, so 0 equal to 4 minus A squared. So A squared is 4, so A is a plus or minus 2. So limit is a start from the H minus 2 to 2. Y value is a 0 to 6. Z value is 0 to 4 minus A squared. We write down the equation here. So integration, in this case, H limit is a minus 2 to 2, but we don't concern about the minus 2 because of that we only want to find the area between the H0 and the H2. So the H limit is a 0 to 2, integration is 0 to 2, Y limit is a 0 to 6, Z limit is a 0 to 4 minus A squared, Sz, dz, dy, and dh. So this is the multi-bed integral. So that in the place of the Sz, we substitute 4 minus A squared, dy, dh. So the Y limit is 0 to 6, H limit is 0 to 2. So that this is the integration differentiations are cancelled. So here you got the Y. So A limit 0 to 2, 4 minus A squared Y, limit 0 to 6 dh. So that we substitute the 6 here. So the integrations are A 0 to 2, 6 into 4 minus A squared dh. So that will be the integration 0 to 2 24 dh minus integration 6 squared dh. So you integrate this one and put the limit, so you got the answer.
So all the lessons you can get from here, which are 26 to the 50 of the highlightcomputer.com video lesson. So you click this link, and from page 26 to 50, you can see the all those lessons. So this is E026. We finish engineering mathematics.